and welcome back. In the last Go video that we did, we talked about just the Hello World program, how to get Go, and how to get going with the spiciness that is golang. In this video, we're actually going to dive in deep into the types, functions, and really the basic programming blocks that you need to get going with Go. All right, enough with the Go puns. Here's a rough syllabus for this video. We're gonna have functions, learn about variables, the built-in types in Go, some of the operations you can do with those types and variables, a bit about memory and pointers, since pointers are an implicit type in Go, and then we're gonna talk a bit about some of the standard library types as well. So we have our main function here where we printed hello world. And next, let's declare a function. As we mentioned before, the main function has to be declared in your Go program or else it just won't compile, it won't run. This is sort of a holdover from C. In C, you also have to have a main function, and that is the main entry point for your program. So really, the first line here after the main function declaration is the first thing that's going to run in your program. All right, so without further ado, let's make another function. Let's call this all about funcs and give it the parens, the opening bracket, and the closing bracket. That is the most basic function that you could have. And in here, we can give it some variables. Let's just give it x, and this is going to be of type int. That's an integer. And super simple. Let's just print line x, and that will just print out whatever number is passed into this function. Let's give it a quick call. And we'll just say 99. There we go. Let's save and quit this. Get rid of that. And then we can go run main.go and see what we get. We print out hello world and then 99. So that variable that gets passed in to our function here, x, is what's getting printed. And you can declare as many parameters as you want, just like any programming language. There could be multiple ints. There could be a string. All kinds of stuff. We're going to get into these specific types, but I want to demonstrate here how you just can pass in all of these parameters that you like. Now, a unique feature of Go is right here, I can actually just go x, comma, y, int, and that is declaring both of these variables here as ints. Kind of cleans it up a bit, which is nice. Let's do x plus y and then something, which is our string. And we can see here, this is complaining because we're only passing in one parameter and we're actually expecting 3 now that we've added y and the something string. So let's go 100 and meow. Save and quit that. Let's go run main.go again. And there we go. We get the 2 numbers added up and then also meow, which we had passed into that function. All right, moving right along. Very good, very good. So that's the basics of how functions work. Now we also can in here declare a return type. So let's declare some kind of integer that we actually return. Now this is going to complain here because it's saying, oh, we have a missing return. So let's return, let's just do 200. You know, I'm not really actually doing any real programming. This is just to demonstrate what we can do with the things that Go gives us. So now this is happy. This is going to return back up here 200. Now, right now, the way that this is written, it's basically ignoring anything that gets returned. So let's actually put this into some kind of variable. So the main way you do that in Go is, we'll just call this my var, is you use the colon equals method. And this implicitly types my var here, which will then become an integer, which we are returning from all about funcs. Now, this is complaining because it's not actually getting used anywhere. So just to make it happy, we're going to fmt.println my var. Oop, there we go. Excellent. So now that's happy. Let's give this a new line to make that look a little better. Now, a pattern that you will see super frequently in Go, and I'm talking like all the dang time, is multiple returns from a function where one of those returns is actually an error. And an error is another type that we have as part of the standard Go package. So we can do int, and then we can also do error. And here we can see that error is getting highlighted, which tells us that it's an implicit type inside of Go. Now this is complaining because it's saying, oh, the wrong number of return values. You need to actually return 2 things. So at this point, we can return nil. And nil is basically saying nothing. It's complete nothingness. It's 0 essentially. So we return no error at all. So now this is going to complain because it's saying, oh, I cannot initialize one variable, my var right here, with two values that are returned out of this function. So another pattern that you see all the time in Go is you will have an error here, and you will say if error does not equal nil, basically the error has occurred, then you go into this if block and then you handle it somehow. This is up to how you do things inside your program. And one way to handle that is very unique to Go, and maybe not a best practice, but is always available to you, is to panic. And we can see, since that's highlighted, it's actually a built-in function. It's very special, and we can pass in the error there. So when we run this, and if we got an error, the program would essentially throw the stack and say, oh, I hit a panic, I'm bailing out right here, I'm done. And it would print out the error that we got here. So if we ran this right now, let's just run it real quick. Go run main.go. We basically, nothing happens. We can see we get that same print statement here, and then also the 200 that we return out of the function itself. So let's actually go down the error path to see what that looks like. So let's go back inside of our file. So what we can do in here is just throw another if block. So let's just do something with an addition here. Let's say if x plus y does not equal 1000, then we can actually return an error. So we would return, in this case, a nil number. We don't actually want to return the int because we have failed at this point. And for our error, we can actually use the FMT package with error f, which basically is a formatted error. So we can say, oh no, not a good time. This is just some kind of error that has occurred. All right, it does not like nil being here, but we're going to just ignore that. Let's just throw 0 in there. That's fine. Really, what's going to matter inside of this program flow is the fact that we will be returning an error in this case. So we return error. This is going to happen if we just leave 99 and 100. We're going to go into this block and we're going to panic. So we can see what that looks like. Let's go run it again. And here we go. We see panic and then our message that we had right there. And then the stack, basically, of where it got in the program. We can see it was in main.go on line 10. Another thing we should talk about with functions, just very quickly, is the first letter of your function name. Now, if it's not capitalized, like I did here, then this function will only be available to this package, okay? That means that if I am importing this package into another library, I will not have this function available. It's private, essentially. Now, if I need to make it public to other packages or to other parts of my program, or even as like a library if somebody was using it from GitHub or something, I would want to capitalize this all about funcs, which would make it a public method in this package. Now, this is mad because I don't have it capitalized. We can fix that just like that. And boom, now it is a public function within this package. Okay, so we're moving right along. That is a very sort of basic pattern flow with functions inside of Go. Okay, so we've learned a little bit about variables already, and we have a good idea of some of the operations, but let's dive a little deeper into the variables that you can declare, and then the types and those operations. All about vars. And we don't really need to give it anything. Okay, so one of the other ways that you can declare a variable is actually using the var keyword. So var, my var, and remember these are scoped, so even though I've already declared my var all the way up here, that doesn't matter because it's in a different function scope. Oh great, so my var is going to be some type. When you declare variables this way, you have to type them because Go is a strongly typed language. Every variable has to be typed or cast to some kind of type. So for this one, let's just make it a string. And remember, a string is just a list of characters denoted by double quotes. That's very important, double quote. A string has to be double quotes in Go. So this is complaining again because we're not actually using it. That's fine. If we were to print this out at this point, it would basically be nothing. When you declare variables this way, Go defaults variables to a default quote unquote nil case for that variable. And the nil case for strings is the empty string. That's very important and will definitely bite you in the butt if you're not aware of it at least. So when you declare variables and you haven't actually assigned them any value, they are by default assigned a empty quote unquote value. So let's go ahead and assign this something. We can call this my var. And because we've already declared it as a variable, we don't have to use the colon. This will fail. This will not work. We actually have to use just the equals. So equals, let's just call this my string. And just to make this happy, we can print line my var. And now this whole chunk will be happy. So right here, this whole block right here, I've already mentioned this a bit. This is essentially the same as doing my other var using the colon equals syntax, my other string. And what happens here is this variable is sort of intuitively cast to the correct type based on what is being assigned. So my other string is obviously a string. It's denoted by the double quotes here. So my other var becomes a string implicitly using the colon equals syntax. And then we can print that out, my other var right there, just like that. Excellent. All right, let's very quickly just go over some of the other types that you're gonna see inside of Go. So there are obviously integers. Integers are single numbers. This could be 1, 2, 3, 4, 5, etc. We can have floating points, and floating points can look like with the decimal 1, 2, 3, 4, 5, 6, 7. That's great. These are all going to complain because they're actually not being used. That's fine. These are 64-bit floating point numbers. Now, it's very important to remember there are bigger numbers in Go, but we'll get to that a little later in the actual standard library packages and stuff. Now, there are other integers and math types and floating point types with varying sizes that they are stored in memory. And we can see that if we declare some number, well, let's give this the bar so we can see it, some number. And if we just type int, we can see that there are all kinds of these things. There's int 16 where it's stored in just 16 bits, 32, 64, just 8. And there's also unsigned integers, which if you're not familiar with what a signed versus unsigned integer is, essentially they can only be positive or negative. They can't flip between one or the other. And these get pretty nasty pretty quickly. If you don't care about the size of your variable in memory, then you don't care about this. All right, so moving along, as we mentioned before, there are strings, and strings are denoted like this. There has to be double quotes between the strings for it to be considered a string. There's also raw strings. So let's just call this my raw string. And what this looks like is between two backticks. So we can say hello, and then the new line that I just put in there is a literal new line in this raw string. So I can say world, and then also there's this right here. This kind of syntax gets pretty gross pretty quickly because it's a literal string with all the new lines and the spacing that you have in your text file here. So you really only want to use these if you have like a giant block of formatted text that you need to actually have inside of your program. So now you might be asking yourself, well, what about single quotes? What does that get me? So these are actual ASCII values. So we can call this my ASCII. And what that looks like is single quote, and then we can put something in here. Let's put the %. What actually gets populated in this variable here is the literal ASCII value for that character, not this % as a string. So if I were to actually print this out, it would just be a number, which is associated with the direct ASCII value for the %. Again, this is one of those things that unless you're kind of like really, if that's what your program is doing is getting into the nitty gritty with ASCII values, shouldn't matter, but it's still very good to know about. And then bytes are also a type inside of Go as well, which can be very powerful. So we can say my byte, and we will have just a cast directly to byte. So let's put a number in there. This 6 will be cast to the byte value for 6. Now, this sort of gives us a hint of the way casting works inside of Go. Now, you just give it the type right here, open parenthesis, closing parenthesis, the thing inside of it you want to be cast, and then your variable will be given that casted value. All right, we just have 3 more, and they are some of the more complex ones, I will say. So first we want to talk about arrays, and then we want to talk about slices, and then we want to talk about maps. So arrays are unique in themselves that they have a fixed length at compile time. Now, it's very, very important. Arrays have fixed lengths in Go at compile time. So the way you can get an array is you can just say my array and then use our good old favorite := symbol. So what we're going to do is the opening and closing square brackets inside the length of your array. So let's just say that this is of length 3. And then we are going to give it a type. There can only be one type for arrays in Go. So let's just say these are going to be integers, and then curly brace, and then all the things, 1, 2, 3. And then that is how you would declare a literal array in Go. Now remember, this array right here has a fixed length of 3. When I run this program, and I cannot modify the length of this array, they are fixed at compile time. And then to actually access this thing, you would do it just like you would do in any programming language. If we want the first element, remember, these are 0 indexed, so we would say 0, and that would give us 1 right here. I'm not really doing anything with this, so it's complaining about it not being used or declared anywhere. If I want the last one, I would use 2. The middle one, I would use 1, so on and so forth. All right, let's get rid of that. So that's not like super duper helpful since they are of a fixed length. There's not really too many reasons you would want that. So there's another uber powerful type inside of Go called slices. And slices are unique in themselves compared to arrays because they have a dynamic size. And the internals of Go handles that dynamic sizing and giving you arrays of non-fixed length, which is really, really nice. You don't have to handle that like you would in C or C++. It's just an implicit type, and they're really easy to get, and they're used pretty much all over the place. So the way you would just get some declared slice is you would just say my slice, this same thing, open square bracket, close square bracket, but we're not going to put a size in there, okay? And then give it the type, and then the same thing, 1, 2, 3, and boom. There's our slice of length 3, and we can start doing stuff with it. And these are super duper powerful because we can do all kinds of stuff like append to these arrays. And the way you do that inside of Go is a little goofy in my opinion, but this is how you would do it, is slice equals, we're basically re-declaring what this variable is, and we would say append, I'm just going to use this completion, my slice, and then we give it the thing that we actually want to append in there, and let's just say 4. And this really could be as many things as we wanted. We could go 5, 6, 7, etc., and it will append each of those in sequence. It's very nice. It's really, really nice that you don't have to manage the sizing of slices in Go. Now, we should really also talk about the make keyword in Go. So let's say that I wanted a slice that is just basically quote unquote empty. Now remember, variables get initialized to their quote unquote empty value inside of Go. So if I wanted an empty slice of ints, each of those would be initialized to 0 when I am given that. So let's actually see that at work using the make keyword. So let's use my other slice, and then what we're going to use is the make built-in function. And we can see here it's expecting a type, so let's give it a type of slice ints, and then the size, the initial size that this thing should be. So it's going to allocate this memory for us and then initialize each of these to their quote unquote empty value, which will be 0 for integers. Let's just make this 5. So then just to pseudocode, let's just talk about what this is actually going to look like. It's going to be 0, 0, 0, 0, 5 of those zeros. Because we declared this and allocated memory for integers, it fills them in with the 0 value, which is 0 for integers. Now I'm really driving that point home. I've seen this bite so many people in the butt when it comes to types and variables and stuff, and I think it's really important. So those are slices. That's all good and well. Next, let's talk about maps. Now, if you're not familiar with what a map is, really all it is a mapping of keys to values. And there's lots of different ways to implement maps. So we're not going to get into how Go actually does that. All you really need to know is that you give a map a key of some kind, and it returns to you that value that is stored at that key. So what that might look like is my key should give you back my value, since you had declared in some arbitrary part of your program that my key equals my value. So let's actually look at what that is in Go. So what you're going to do is you're going to say my map is equal to a map, and then you use the type. So let's just say string, and then the actual return type, let's say string, and then you can start declaring things inside of there. Now, what this gives you right here that I've basically initialized is a completely empty map. There are no keys that associate to any values. You can start adding keys and start adding values. You could say my map, and we have the access, my key, and that will equal my value. And then that gets stored inside of that map there. Oops, that's an extra character. You can also declare this arbitrarily at the beginning of initialization. So we can say my first key, and that's going to map to my first value. Now, note the colon inside of here. This is pretty much the way you do this on initialization, or when you're declaring a literal map, is you use the colon syntax. Go can get a little finicky with some of its syntaxes. It's a simple enough programming language, and once you figure it out, it makes a lot of sense. But don't be afraid to look stuff up, even like the most basic things like, how do I initialize a slice or something? Go is very unique in the way that it declares some of these literal values. So look it up. It makes sense once you start really using it and getting going. So that's pretty much all of the values and types and how you declare variables. We should really talk a little bit about memory and pointers, which I know is kind of gross and scary. You're not going to deal with them a lot in Go. Go is a quote-unquote memory safe programming language, and you can really stay within the constraints of that safety without having to dive into the weeds too much. But I do think it's important to know about, at least, since it does give you the keys to that car. You should at least know maybe not to drive the car. So func, we're going to say all about pointers. So I think the really easiest way to demonstrate this and really talk about it is to just use it within this function. And let's just say that inside of here, we are actually going to return a pointer 1 and pointer 2, and these are just going to be pointers to ints. Now, the biggest thing that I just did here is use this asterisk. And the asterisk is basically saying that this is a pointer to some memory address. So deep within the confines of this computer, there is a lot of memory, and those memories all have addresses. Those addresses look like ABC 123, ABC 123 before, so on and so forth, 125. You get the idea. They're essentially hex values that associate to a physical memory address deep within the bowels of the computer. So really, within a programming language, when I say, hey, give me a variable of type int, what's happening is the computer and the programming language are going within the memory and saying, okay, this needs to be 16 bits or whatever. So I need memory address ABC123 through ABC, whatever that is, plus 16. Let's just call it 30. I'm not going to do the math. So those memory addresses are then really associated to that variable. So then the computer will say, okay, here's your variable, but really it's just these memory addresses. And the computer knows how to disassociate that variable name into those memory addresses. Now, when I say, well, what's the memory address? What I'm really asking is asterisk, this might be my variable or something. And that asterisk in itself is a type in itself. It's a pointer type. It's a literal memory address. It points to some memory. So then the computer's going to say, okay, here's the memory addresses, and it will say ABC 123 through ABC 130, or whatever it's actually going to be. So if I were to go and actually print that, I would see the literal hex value for that pointer for that memory address. So let's see that in work, actually. We can get an allocated memory address, the pointer, for something by using the new keyword. So we can say new int. And what this gives us is the literal memory address for that allocated memory that is an integer. So P is now of type pointer. P is a pointer to some memory. So that's all good and well. We can return P. So down here it's going to be mad. So let's just start this out with return P. Okay, great. It needs one more. let's give it some arbitrary thing. Let's do it kind of the opposite way. There's another way to access memory and get the actual memory address pointers for these. And the way you do that is using the ampersand character, which gives you the reference for something. And you can only reference variables, which is sort of the scenario we went through here, where we're like, well, what's its memory address? We would really use the ampersand to get that. So let's declare a variable, same variable, my int. This is going to be of type integer. Let's declare it as something. My int equals 55. And then what we can do down here is dereference that with the ampersand and say my int. And then all should be good and well. Oop, and this is going to complain because I didn't use the colon, biting me in the butt. There we go. So now P is a pointer. P is pointing to some literal memory address because we asked for the memory address when we initialized it. And then using the reference to my int, where we're saying, okay, we want the actual memory address of my int, that becomes a pointer as well. And again, pointers are gross. You're almost never going to use them in Go. So I think it's important to know about them. It gives you the keys to the car to do this stuff, but 99% of the time you're not actually going to. So finally, last but not least, let's talk about any additional types that exist within the standard library. And most of these actually exist within the map big library, and we don't declare that here. Remember, let's go all the way back up to the top of the file where we do imports. If we wanted that library, what we would do is give that the opening and then here, and then we can actually stick that in there, and there we go. That's fine. Now this is going to complain because it's like it's imported but it's not used. We're not actually using it anywhere with anything. But big gives you the really big numbers, like the bigger than 64-bit floating point numbers that you would need, or exponential numbers, or imaginary numbers, all this stuff. The math library has so much stuff in it, but it's part of the Go standard library. It comes packaged with your Go installation and gives you a bunch of additional types. Go read the documentation if you need that stuff. Let's talk about some of the operations that you can actually do with variables and stuff. They're all here. It's all the same stuff. You got plus, where you can add numbers, subtract, where you can subtract numbers. You have divide, where you can actually divide numbers, so on and so forth. And also multiplication. You can multiply numbers. Great. There is the modulus operator as well, which gives you the remainder of some division operation. And then as far as logic operators, there's all the typical ones. There's AND, which is two ampersands. There's OR, which is two of these pipes. There's equal equals to see things are equal. There's not equals, which you saw me use earlier. They're all here. It's all good stuff. And those are really the biggest ones. I wouldn't be surprised if there were more that I just don't use or just don't know about. But yeah, those are all the biggest ones. They're all here for the party. It's a pretty typical programming language stuff. Well, everybody, that's pretty much it for this video. I know it's a lot to take in, but remember, you can always look stuff up. You can always Google. Go is an extremely powerful programming language, and it's a journey. I'm still learning stuff day to day. I'm still finding stuff out that I learn, and you are on this journey as well. Be well, my friends, and I will catch you in the next video. Peace.